for that is because in the real world, we don't necessarily know what the population standard deviation is like we would need for a z-test. Well, here we go. We're going to go through the entire process of a hypothesis test when we don't know the population standard deviation. This is problem 12.6 from your text. It's one of the assigned problems. So let's follow along as we go through the complete four-step process in solving a T hypothesis test. So heat through glass. We are investigating the transmittance of heat through glass. Glass is typically a transmittance of 1 watt, you might ask. Well, 1 watt of heat per square meter per degree in Celsius of difference between the inside of the glass and the outside of the glass. So it's kind of a complex thing to think about, but for the process of understanding what t-tests are all about, we just need some numbers to work with. So good windows are going to have a smaller number, and less good windows are going to have a bigger number than 1, okay, as heat passes through. We don't want heat to pass through. We want the inside of our house to stay cool when it's hot outside, and we want the inside of our house to stay hot when it's cold outside. So less heat energy passing through the window is a good thing. So we tested some glass. We tested 11 different samples of glass from this particular company, and we found a mean of 1.181, so it's transmitting a little bit more heat here, it looks like, in the sample. We see the sample standard deviation. Our sample size of 11, degrees of freedom is going to be 10. Kind of feel like a weatherman here. If only I had a green screen. Anyway, is that enough for us to say, yes, this company's glass is different than what glass typically is, that this is transmitting more heat energy than standard glass? We're going to conduct this t-test and we're going to find out. We start with our step 1, where we outline everything going on in this problem. We talk about the population, the parameter, we establish a null hypothesis, an alternative hypothesis, and very important, we set up our alpha in the beginning here, alpha 0.05, to keep it standardized. So the population, what are we talking about? Our sample was this particular company's glass, so our population is all of this company's glass. What's the parameter that we're looking for? It's the watts of heat per square meter per degree Celsius of difference, and so we're just going to say energy transfer. And we're looking for the true mean, the true energy transfer. My null hypothesis is this company is making the same quality glass as the standard, that the true mean is equal to 1. The alternative, we suspect this company's glass transfers more energy, so mean being greater than 1 is going to be my alternative hypothesis. There we go, that's my step 1. All right, step 2. Step 2 are our conditions. Now the conditions between a z-test and a t-test have not changed. We're still looking at, did our information come from a simple random sample? In this case, nothing was told in the base problem that it came from a simple random sample, so we must assume. Do we have normality? Let me look at the question here real quick. Uh-oh. Sadly, we don't have normality either, so we have to assume here. This really makes for quite a weak argument when we go in and state our conclusions. So the assuming here and the assuming here weakens the credibility of this study. And lastly, independence. Independence, we know our population has to be 10 times bigger than our sample size. So my population, all glass, is greater than 10, or equal to, I suppose, 10 times our sample size of 11. We're going to assume that this company, and sure, we're good to go there. I don't think a company is going to make less than 110 sheets of glass and be in business. Though the glass they're making conducts quite a bit of electricity, so maybe it's a lower end product. Maybe they won't stay in business anyway. So there's my step 2. Unfortunate that we had to assume a simple random sample and assume normality. Calculations are going to look very, very similar to what we did in the z-test. T is going to be equal to my sample mean minus my hypothesized mean divided by a sample standard deviation now over the square root of my sample size. So I'm just going to sub in my numbers. My null hypothesis mean was 1 from step 1. Standard deviation. I'm getting these from calculations I did before. I was given a set of 11 numbers and I ran them in my calculator. And my sample size was 11. That's going to give me a T of, written down right here, 8.95. Now that is huge. 8.95 standard deviations away from the mean is incredibly rare. We know that only 0.3% of all observations occur outside of 3 standard deviations. So to be 8.95 standard deviations away from the mean is very, very rare. That's going to give us a probability that is less than 0.00001. We looked that up on our green table. 8.95 doesn't even exist. It's off the chart. So our probability is practically 0. So the odds of this happening are practically 0. So let's take that information into our conclusion. All right, our step 4 is our conclusion. Now our conclusion, as you recall, has to have 3 things. We need evidence. We need to make a choice, and that choice is to reject or fail to reject the null hypothesis. And then we need to put that choice into context with this problem. So here's the evidence. My p-value of approximately 0, our p-value is really, really small. That is less than alpha at 0.05. So that makes our choice very, very easy. We must reject the null hypothesis. And in doing so, we can safely say that it seems that the glass transmits more heat energy. And you might want to put an asterisk on this and say, however, our conclusion is weakened because we didn't have a simple random sample and we don't have a normal distribution. So though this would be our conclusion, typically our results are a little suspect because the study is less than ideal. Okay, so maybe further evidence, additional samples would take care of the normality thing. As soon as we pass that threshold for central limit theorem at a sample size of 30, that would make us more comfortable there. Getting ourselves a random sample, that would do good things for us too. We could apply that to the population with a lot more confidence. So there it is, guys. 4-step process, very, very similar to what we did with our z-tests.